Hello guys, welcome to the class of Euclidean Geometry, the matric one, whereby we will be doing this lesson for this Euclidean Geometry for grade 12 part. So, but if we need something that we have to remind ourselves with, we will definitely go back to some grade 11, grade 10, grade 9 part to just remind ourselves of some theorems like midpoint theorem. So, okay, now we've got some mini paragraph that we need to go through just to have some idea of what we are going to look at. So they are saying to us here in this chapter, we will be studying the concept of ratios. We know what the ratio is, just to remind you of what the ratio is, guys. The ratio is, let's say, I'm talking about the quotient A over B. You can express these fractions in terms of the ratio. You can write this in the form of A is to B in the ratio form. But this is still the same as this quotient on this other side, where your numerator is being written on the left-hand side, and your denominator B will be written on the right-hand side of the ratio. And then the ratio sign is this colon thing, these two dots here. Okay, fine. We are done up to this part. Proportionality and their similarity. We will talk about what the proportionality is and what the similarity is. Cool. Now, we will focus on the triangles in this Euclidean geometry that we are going to talk about. Oh, remember in grade 11, you guys talked about some circle Euclidean geometry, blah, 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 blah. So now we are going to work with triangles. Oh, that's funny, eh? Okay. Now, let me erase those shapes of mine there. And then, okay, let me go. We are here. You will learn 3 new theorems in grade 12. Besides those ones that you have been talking about in grade 11, the Tancred theorem, midpoint, or no, not midpoint theorem. What are those theorems? It's Tancred theorem, angle at the center is 2 times angle at the circumference. We are now no longer going to talk about those theorems now here in grade 12. We are going to talk about these 3 new theorems. So at the end of this chapter, you will find the summary of the principle of this. Okay, fine. Then now the triangle proportionality theorem is the first theorem that we are going to talk about. Okay, they are saying here a proportion is the ratio that remains constant. What do they mean about that? Okay, we will see. And then when we say that 2 line segments are divided proportionally or in proportion, this is the same thing. When we say lines are divided proportionally, we mean those lines are divided in proportion. Okay, it means that they are divided in the same ratio. For example, let's say maybe we have 2 lines of ours here. Let's say we have line here. This line of ours is AB, fine. And then we've got another line C, D, and then all right. And then okay, I cut this line again here. And then I say to you, I divided these 2 lines in proportion, or I divided these 2 lines proportionally. I mean to you, if maybe I take this portion of the side, let's say this is my E. I take AE, let's say AE, the ratio, and then again I take this other side, EB. This ratio will be the same as when I take this ratio let's name this point maybe K. CK ratio KB. KB. Perfect. Okay, I hope that makes sense. Now let me erase this demonstration of mine here. I erase. Fine. Now we can go to this theorem one that I am having here. Let me scroll. I've got this theorem one here. Let me also erase these things here. Fine. Okay. Perfect. Now we can see, guys, that we are having some triangle here. Like we said earlier that in this part of matric, we are going to talk about some relationships of the lines of these triangles that we are going to talk about. Mostly, we are going to talk about triangles in this greater Euclidean geometry. So perfect. Here, in proportionality theorem, you will always be given a triangle for proportionality theorem. This triangle A, B, C. Okay, triangle is that quadrilateral with three corners, three lines. A, B, C corners. This line AB, AC is a line, BC is a line as well. So, and then the other thing that you will be given on this triangle is that you will be given a line, just one line that will be parallel to another one side of this triangle. So you can see that this line PQ is parallel to this line BC. Okay, interesting. Now that's where proportionality takes over because, okay, at first it was just a triangle. I mean, we all know triangles. Okay, at first it's triangle that is like this, where there's A, B, C. It's just a clean triangle. Okay, now on this blue triangle, we are not yet convinced that, okay, proportionality theorem applies on this triangle. Why are we not yet convinced? Because now there is no that line that is parallel to the other side of what? Of this triangle. So now, since I have these other parallel lines to the side of the triangle, now proportionality theorem is applicable on this triangle. You can say prop theorem applicable. Why do we say proportionality theorem is applicable? Because we've got a triangle and you've got a line that is parallel to the third side of this triangle. So proportionality theorem is applicable. I hope that makes sense to you guys. Okay, now let's go and see or have a look on how proportionality theorems work. Okay, you will be given, like they said, you will be given that there is a triangle in front of you on the paper. You are writing the exam there is a triangle ABC. That is a triangle. And on that triangle, you are also given that PQ, which is that line that they thrown there, is parallel to BC, and PC is the other line or the other side of this triangle. So now, since this line is parallel to this line, we go back to that thing of ours that says now proportionality theorem is now applicable. Okay? Interesting. Let's go. Now, if proportionality theorem is applicable, this is how proportionality theorem works. You will go to the side that is the one that is being divided by that line that is parallel to the other side of the triangle. I hope this makes sense. Let me repeat this statement that I'm talking about. I'm saying how proportionality theorem works. Okay, there exists this triangle of ours. Okay, fine. And then on that triangle, we have drawn the line that is parallel to the third side of a triangle, right? Okay, let's say this is side one, side two, and side three. Now we are done. We are done working with side three. we are now going to focus on side 1 and side 2 only. Okay, fine. We ignore side 3. Perfect. You go to side 1. You divide it into some ratio. Let's say that ratio A, P, and P, B. Okay, you move from the side A to the point of that line that we have drawn, that is parallel to the third side of a triangle. Then you move from that point P to B. You do the same thing on the line 2. You go from point A to that point where we have drawn that line that is parallel to the third side of a triangle. Perfect. Now we go again from Q to C. Now we have divided those sides. Now, this is how proportionality theorem works. On the side 1, you will take the quotient of the ratio of those sides. Let's say AP. AP is equal to P. I'm sorry, they are not equal to AP over PB. This ratio is equal to the ratio of this side line 2. AQ over QC. This is how it works. So remember, in Euclidean geometry, the statement is being accompanied by the reasoning, because remember, if maybe you don't put the reasons in your statements, you're not going to get the full marks. So every statement that you are putting in Euclidean geometry needs to be accompanied by some reasoning. Okay. Yeah. So now this is our statement. We said AP over PB is equal to AQ over QC. Okay, perfect. Now, that can also work like this. We can say AP over, maybe we say AP over, we took AP over everything AB, now AB. If you did it like that, also on line 2, you have to do it like that. You take AQ over everything, which is now AC. Okay, now it's messy here. Let me erase this thing here. Oh, I'm sorry for that. I was just erasing this mess that I had here. I was saying AQ over QC. QC. If you did AP over AB, also on that other side, it should be AQ over AC. Then that is the statement only for now. So remember, in Euclidean geometry, you have to put the statement and some reasoning to accompany that statement. So why do we say AP over PB is equal to AQ over QC? Why? It's because proportionality theorem was applicable here. So my reasoning behind that statement will be proportionality theorem. You can just write prop theorem. Why do we say this is a prop theorem? Remember, we said proportionality theorem is only applicable if in this triangle PB is parallel to BC. So always we will use this reasoning that, okay, AP over PB is equal to AQ over QC. Fine. Then your reasoning being prop theorem, and then after you stated that this is a proportionality theorem, you need to convince the person that you are talking to that why do you say this is proportionality theorem. Then you say you parallelize that PQ, sorry for this is PQ, which is this line, is parallel to BC. Fine. I hope that makes sense. Or also this reasoning is acceptable. You can use it that there is a line that is parallel to the side of a triangle. Fine. We can move to some of the extra notes whereby you can just play around this proportionality theorem with the side. You play with the side. Fine. Now we've got these cases we've got this triangle here. Let me zoom it a little bit. Fine. Now I've got my triangle here, ABC, fine, and my line PQ there that is parallel to BC. Sharp. Now we talked about this one on the above demonstration or example or whatever you can call it, that AP over PB, this side, is equal to, we come to this side, AQ over QC, fine. And then now you support that statement with reasoning that this is a proportionality theorem. Why do we say this is a proportionality theorem? Because PQ is parallel to BC. Perfect. We are done with that one. Let's come to this one now. Erase. Oh, fine. And then we have PB now. We started here. PB over AP. So if on this side you started with the lower one over the top one, also on this side you have to start with the lower one over the top one. So it will be PB over AP. That will be equal to QC over AC. Why do we say that? Why do we say the ratio of this side is equal to the ratio of this side? Why do we say that? Yes, the reason is because proportionality theorem is applicable here. Then the reason comes again. Why do we say proportionality theorem applies here? Because this line is parallel to this line. PQ is parallel to BC. Fine. I hope that makes sense. Now, let's go to the next demonstration or the next diagram on this side. Fine. We are having this triangle this side, okay? I think it will be the waste of time. This thing of me erasing and writing, erasing. Let me just go ahead. We are having this triangle again, ABC, and we are given some line PQ is parallel to BC. Fine. Let's see what we are having. We are having AP over the whole side AB. We should do the same thing also on the other side. AQ over AC. So AP over AB should be equal to AQ over AC. They wrote that. That is the statement. Why do we say this ratio is equal to that ratio? Because that is proportionality theorem. You write your reasoning. Prop theorem. Why do we say this is the proportionality theorem? Because PQ is parallel to BC. You see, so same applies with these ones, guys. You just play around those ratios right there. Then we can proceed to the next corollary, which is the midpoint theorem. I think you guys know midpoint theorem from grade 10. So this corollary is saying a line drawn through the midpoint of one side of a triangle and parallel to the other side bisects the third side. I always ask my students the definitions of these terms bisect, intersect, you know. I mean, what does bisect mean? So bisect mean we cut something into two equal parts. Let's say we are talking about this line A AC. And then we are saying another, oh, let me change the color of my pen maybe and use the red one and say the red line is bisecting the line AC. What do I mean by that? I mean this line AC is divided into two equal parts by this red line, meaning the distance from A to the red line is equal to the distance from the red line to the C there. So it is bisected by the red line. I hope that makes sense. So let's go back to the statement and digest that term bisect. And now think about it. What does it mean if it bisects the third side of the triangle? Perfect. Now, we are talking about this triangle of ours here. This is the triangle of ours here. Okay. It's A, B, C. Here's my beautiful triangle. And then look, a line drawn through the midpoint of one side. So let's say this is the midpoint of A, B. What is the midpoint? Is that this line is equal to that line. From the point to A is the same as from the point to B. Okay, this point bisected the line AB. Perfect. Now we draw this line such that this line is parallel to the other side of the triangle, such that this line is parallel to this one. Perfect. Automatically, that line that is parallel to the other third line of a triangle bisects the third line of a triangle. So it bisects this one. What does that mean? The distance from A to the line will be equal to the distance from the line to C. That's what this theorem says. Meaning now, when we go for the proportionality, we will say the ratio, if this is our P, this is our Q, we will say AP over PB is equal to AQ over QC. You're listening? For this one, because all these sides are equal, you can say midpoint theorem, but you are still allowed to go for the proportionality theorem. Fine, let's go to the next example. We have got example one here. We are given a triangle. We can see that, but then I would always advise you guys to read the statement that you are given, just to highlight some data that you are given. Okay. They are saying the following sketch. We are given that PQ is parallel to BC. So PQ is parallel to BC in this triangle. What does that imply? That implies proportionality theorem is applicable. Perfect. Now, we are given AP as 10 here. Excuse me. We are also given PB here is 6. Okay, we are given AQ there is 15. Then we are given this X. And then we are required to find QC is X. Because they say to us here, determine the value of X. Now we said proportionality theorem is applicable here. What are we going to do? We take the ratio for this side, or the side one, the ratio AP over PB. So we say AP over PB, that is equal to the ratio of this side. So that will be equal to AQ over QC. Why do I say these ratios are equal? Because proportionality theorem is applicable. Proportionality theorem is applicable. Why do I say proportionality theorem is applicable? Because PQ is parallel to BC. Perfect. Just like that. Now you substitute the formula that you are having so that you solve for the value of X. What is AP? AP is 10, right? Fine. What is PB? It's 6. What is AQ? It's 15. What is QC? It's X. You do your maths now. I mean, grade 8 maths. You cross multiply. You are going to have 10x is equal to 6 times 15. What is it going to be? I'm so not good. Let me quickly punch my calculator. I'm so not good in mental maths, guys. So 6 times 15. On my side, I get 90. Perfect. So I divide by 10 on both sides. Therefore, my x is 9. Therefore, my x is 9. I hope it makes sense. Perfect. Now we can jump into the next problem, which is this one. Let me erase this thing here so that I can have some space to write on. This is so not horrible, guys. It's just the matter of knowing how to play around with proportionality theorem, play around the size of the triangle, have fun, solve the value of x. So now we are having this B. Read the statement as usual in the following sketch. We are given that ST here is parallel to PQ, okay, in this triangle. Therefore, proportionality theorem is applicable. Fine. We are given PS9 SR27, we are given QR34. And then now what we have to determine? We have to determine some TR. Fine. Now you can go on that other side. You see what you are required to look for. You are required to look for TR. And then what do you have? You have the whole of that side, QR. Then you highlight the same thing on the other side. You highlight RS, just like we moved from this point to the line, that one that is parallel to the third side of the triangle. You move again on the side from the R, you move to the line that is parallel to the third side of the triangle. Again, we highlight everything on that other side, just like we did this side. Yeah. Now, how do we use proportionality theorem? We use TR from the R to the point that is parallel. So it's going to be RT all over everything RQ. Point that is equal to RS over everything RT. Why do I say these are equal? Proportionality theorem. Prop your rem. Why do I say this is the proportionality theorem? Because PQ is parallel to ST. Perfect, just like that. And now you substitute into your formula. What is RT? What is RT there is the one that we are looking for, or TR. It doesn't matter. RT over RQ. What is RQ? It is 24. What is RS? There is 27. What is RP? 27 plus 9. What is it? 27 plus 9 is 33. Then 33. Then from here, you do your maths. I mean, you solve for that RT. You cross multiply. You're going to have RT 33. That is equal to 27 times 24. And then you're going to divide by that 33 on both sides. Then your TR or RT will be equal to whatever you will get when you punch this thing on your calculator. And then, yeah, now is it 33 here? We had 27 plus 9 there. 27 plus 9 gives me 36. So this will be 36, 36, 36, 36. Fine. Now these are the solutions to whatever we did up there on the example 1. Sharp. Now we can go to the ratios and fractions. I'm just going to talk about what I already said. So remember that the ratio can be expressed as a fraction and vice versa. Like I said, this is the ratio AB is to BC is equal to M is to N. That can be written as a fraction. The one that is on the left on the ratio is going to be the numerator. The one that is on the right on the ratio is going to be the denominator. M will be the numerator on top. The N will be the denominator on the bottom. Fine, perfect. From the fraction to the ratio, it's possible. From the fraction to the ratio, it's also possible. For example, if you're having the ratio AB is to BC, L2 is to 3, you can write AB over BC as 2 over 3, just like that. So now problem solving involving the ratio and the length. Let's say if two line segments are in a ratio mn, we can represent their length by mx and nx respectively. If AB is to BC is given as this ratio m is to n, let AB, you give this m a variable x. You also give this n a variable x, such that it becomes mx and that one becomes x. So if you give the first variable x, the second variable you give the variable that you gave the first one. I mean, you can't give them different variables. Like maybe you can't say m is x and you say n is y. No, you will be wrong. You should give the same variable throughout. If the first one on the ratio is x, the second one should be x as well. Now, this is what we said here. Fine. This technique is very useful in solving problems where combination of ratios and length are given. Fine. Example 2. We have example 2 here. They say in the sketch alongside, we are given the ratio AB is to BC that we can write as AB over BC as 7 over 3, right? Because ratio can be written as the fraction. So this one will be the numerator, this one will be the denominator. This one will be the numerator, this one will be the denominator. Fine. They say AB is 7. Where is AB? This is AB. So you write 7A. Fine. BC is 3. You go to BC, you write BC is 3. Fine. Now remember, we said on the ratio, we give some variable. So 7, you give it a variable, say A. A B, we give it, the other one, we give it B. Now, this is wrong. Why? Because we said when you introduce the variables, you can't introduce the variables that are not the same, A and B. Now this is wrong. And then if I write A there, now this is right. The ratio of this side needs to have the same variable A. If I give this one B, I should give this one B. If I give that one C, I should give this one C. If that was 7x, this should be 3x. I hope that makes sense. Let's go to the other information that are given. AB is 21 units and AE is 20 units. Perfect. Now we are required to find the length of BC, which is this one. Fine. So in order for us to calculate this thing, look, we are having something like this. Okay, this is interesting. We are having A, B, and the C. So from A to B, we are having something like 21 units. And from B to C is something that we don't know. Let's say that is X. Fine. From A to B, according to the ratio, what do we have? We have 7A. Fine. From B to C, we have 3A. Okay, now we can come here from here. From here, we go all the way to B. From A to B, on that length in terms of units is 21. But with respect to the ratio, it's 7A, right? But AB is AB, right? It will never change. AB will always be AB. What is AB with respect to the units, the length or in terms of units is 21 units. Perfect. Then in terms of the ratio, what is AB? It is 7A. Perfect. We solve for the value A here. We divide by 7, divide by 7. What is the value of A? The value of A is going to be 3 sharp. Now, what was the question asking us to do? Okay, it requested us to find the value of BC. We go back to the value of BC. Okay, X is equal to 3A here. Why? X is equal to 3A here. Then we have the value of A. We want the value of X. We say 3. What is the value of A? We found it here. It was 3. Perfect. 3 times 3 is 9. So that value BC is 9. Just like that. Fine. Now let's go to B. We have to find the ratio AG over GD. This one, this one, this one, this one. So let's focus on this triangle, guys. This triangle, this triangle, this triangle. We have this triangle here, and we are given that this line is parallel to this one. Therefore, now proportionality theorem is applicable, isn't it? It is. Yes. Now we have the ratio on this other side. We have to relate it to the ratio of this side. So what does that mean? What does that mean? It means that, okay, if we are looking for AG, which is this part over GD, that must be equal to AB over BC, right? AB over BC. What's the reason behind that? It is because of proportionality theorem. Why do we say this is proportionality theorem? Because BG is parallel to CD, right? I hope that makes sense to you guys because, hey, we are so going to use this a lot. So it's just a matter of you guys playing around this proportionality theorem. Now what to do next? Okay, we have got number C to look on. What is number C requiring us to do? Let me have a look. Okay, sorry for that. And then we can go to the last one, which we are required to find the value of FE. So where is FE? Here is FE. Here is FE. This is an interesting question, eh? Okay. Now, how are we going to find that one? Okay, let me erase this mess here. Let me erase my mess. Okay, we said now this ratio AG is equal to AB over BC. That is the same as 7 over 3. Okay, perfect. Now we are going to this one, and then let me have a look on this one. We are having a F here. Okay, we want FE. Okay, and then we have something. Okay, now for FE, we still can say AF over FE is equal to AG over GD. Perfect, just like that. Why do we say this? It's because proportionality theorem is applicable even on this triangle. Why do we say proportionality theorem? Oh, let me write my reasoning, because you are also required to write the reasoning in order for you to get full marks. So proportionality theorem. Why do I say proportionality theorem? Because GF is parallel to DE. Perfect. Now, I substitute the information that I'm having. Now, how? Now, that is the reason. Okay, this is 7, but because we can't say this is 7a because we used the variable a on this other side. Let's say this is 7b, this will be 3b. Fine. On that other side, now because the ratio of this side is equal to the ratio of this side. Now we can also say that is 7c. We can also say this is this, just like that. Okay. Now this is funny. Look. When you look here for AC, AC in terms of the length is 20, right? Then AC in terms of the ratios is this 7C plus 3C, which is going to be 10C. You solve for C, divide by 10, divide by 10. Therefore, my C is equal to 2. Then now to solve for FE, the ratio there we have 3C. Then that 3C, you can simply say that is going to be, you can say FE is going to be 3 times my C is 2. Therefore, that is going to be 6 units. Then you are done just like that with that one. Then I think this will be the end of the lesson for today, guys. And thank you for watching. I will see you in the next lesson. Nexa is out.